In this lesson, we're going to be taking a look at solving single-step equations, so ones where we only have to do one thing to them. And we're going to be doing it though with negatives. And this is particularly important because oftentimes when someone looks at some of these equations, they get a little mixed up about what is actually being said in the first place, and it throws off the solution for them. So there's two different things that sometimes I'll see people interpret this meaning. One thing I'll see people say is that this is the same as -6 times p equals 54. The other thing I'll see is I'll see people say that this is p subtract 6 equals 54. And the question is, which is it? Well, it is in fact this first one. We have that -6 right next to the p, and so that's meaning multiplication. But it's certainly understandable why the second option, which is not it, might seem like it should be. Because you'll notice that you do have the exact same characters written over here as you do in the original. We have a negative symbol, we have a 6, we have a p, and in math, especially when multiplying and stuff, you can just rearrange those and have it mean the same thing. So I understand why people end up getting a little bit mixed up on that. However, whenever we write the negative in front of a number like this, we have to remember that it's not saying subtract. When we see something like -6 like that, it's telling us this number is not 6. This number is actually -6. It is a completely different number. It just happens to be the same distance away from 0, but it's in the negatives. And so it doesn't mean that we should be subtracting. It means that the number is negative. And if you get that straightened out, then this problem then becomes a lot easier. Because knowing that this is actually -6 times p tells me that if I want to get the p by itself, I have to undo that multiplication. That means I need to divide both sides. And I'm multiplying it at the start. My original equation, I'm multiplying it by -6. Therefore, I'm going to divide both sides by -6. And so when we do that, the -6 divided by -6 equals 1. They cancel each other out for that reason. So all I'm left with is 1p, which is just p. We don't have to write the 1 in front. That's why it goes away. And then we do the 54 divided by -6. Well, I know 54 divided by 6 is 9, because 9 times 6 is 54. And I'm doing a positive divided by a negative, and a positive divided by a negative is a negative. Therefore, p equals -9. And then that one is done. We need to do nothing else because we have our answer. In our next problem here, we have -10 equals -12 plus u. And we're trying to solve this one for u. And this is another one that sometimes will confuse people or trip them up at least. Because the first thing that we would tend to do is we tend to say, okay, well, I want to get rid of the addition. And getting rid of addition means that we should subtract from both sides, which is fine, and that's going to be good. That will help us out here. So we're going to go ahead and subtract from both sides. The question is, what are we going to subtract from both sides? And the error that I'll see people make is that they will subtract 12 from both sides. But subtracting 12 from both sides won't really work, because you'll notice that if I do -12 minus 12, that would actually equal -24. That didn't make the -12 go away. Why not? Isn't addition supposed to make it go away? Well, yes. When we undo the addition by subtraction, it does make it go away, but we have to subtract out the exact same number. Our starting number up here is -12, not a +12. So we have to be subtracting actually a -12 from both sides. And so that's actually how we'd be doing it. Now, some of you are saying, wait, I thought I'd just add 12 to both sides. Can't I just do that? Yes, because minus a negative is in fact the same as adding a positive. So if instead you wrote +12 and then +12 like that, that is also perfectly fine. Either way of writing it is valid because it will make the negative 12 plus 12 here add to 0. And that's what we want. We want that to go away. And adding to 0 goes away. And so whichever way you write it, it actually operates the same way. And on the left side, you get the same answer. Negative 10 plus 12 is a positive 2. And negative 10 minus a negative 12 is also 2. On the right side, the negative 12 plus 12 is 0. The u is left behind, so it equals u. Now you might be wondering, wait, the variable's on the right-hand side. I'm used to my answers having to have the variable on the left-hand side. Like, shouldn't it be u equals? It doesn't have to be. It means the same thing. Whether the u is on the left or the u is on the right, we still know what u equals. We still know that u equals 2. In our last problem for this video, we're going to be taking a look at this division problem. And again, this is another one where the negatives involved could end up tripping some people up if we aren't careful. And specifically, the problems that can occur with this one come from where this negative goes in the fraction itself. So the question normally is that going to be negative a over 3? Is it negative a over negative 3? Or is it a over negative 3? Where does that negative go when we put it in there? Well, let's answer that by actually taking a look and seeing what each of these would give us. If I do a negative divided by a positive, I get a negative. Negative divided by positive is always negative. And so this would be a negative number. What about this next one? Negative a divided by negative 3. And yes, fractions are the same as division. That's why I'm dividing here. So a negative divided by a negative is a positive. Okay, and then the last one is a positive divided by a negative, which would also be negative. Now notice over here, I want the entire thing to be negative. Well, that means that this one worked and this one worked, but this one did not. If I put the negative in both the top and the bottom, it basically cancels itself out. And so you can put the negative into the top or into the bottom as you wish, whichever one seems the most useful for solving your particular problem. Now in this case, because I'm actually trying to solve for a, and I want to get a by itself, I would rather my equation over here be written with just a positive a rather than the negative a that I had up here. And so I'm going to choose to put that negative in the bottom just because it makes my life a lot easier. So that's the first thing I'm going to do here. Just to kind of show you, just to kind of illustrate, I'm going to rewrite this over here. 7 equals a over negative 3. It's the exact same thing. It just now is going to be a little bit easier to know what to do next, because if I'm going to try to solve for a, and right now the a is being divided by negative 3, what would I do to both sides to get the a by itself? Well, I'm undoing division, and therefore I would need to multiply both sides. And I multiply both sides by whatever I'm dividing by. So I'm going to multiply both sides by the negative 3. And so on the left-hand side, when I do that, 7 times negative 3 is negative 21. That will equal. Now I'm going to do a divided by negative 3 times negative 3, and that equals a. Those negative 3's cancel each other out. And so a equals negative 21 is my final answer. Now, I'm going to step back for a moment. If you got that one and you feel like you understand it pretty well, you can go ahead and leave now. You're done with this video. But I know there's somebody who's saying, wait, why does a over negative 3 times negative 3 equal a? And so if you are in that boat, I'm going to explain that here. So I'm going to write that out as a separate little problem down here. So I'm going to be doing a over negative 3 times negative 3. Now, notice I'm multiplying a fraction by something. I know how to multiply two fractions together, so I'm going to write them both as a fraction. So it's going to be a over negative 3, that was already a fraction, times, now I want to write negative 3 as a fraction. Any number can be written as a fraction by just writing it over 1, because negative 3 divided by 1 is still just negative 3. All right, so now they're both fractions. I did that because I now can use what I know about how to multiply fractions. In order to multiply fractions, we multiply straight across the top and straight across the bottom. And so in order to multiply these two fractions, I'm going to multiply a times negative 3 on the top, which gives me negative 3a. And then on the bottom, I multiply the negative 3 times 1. And negative 3 times 1 is negative 3. Notice in our fraction here, we have the same number multiplied into both the top and the bottom. We have a negative 3 in both the top and the bottom. And anytime you have something in both the top and the bottom of the fraction like that, it can cancel out. That's because negative 3 divided by negative 3 is just 1. And therefore, when we cancel those out, we're just left with a over 1, which is a, because anything divided by 1 is just itself. So that's why multiplying by the negative 3 did indeed cancel out that negative 3 that was in the denominator of the fraction.